Hi students, for this video we'll be talking about oxidation and reduction, which is chapter 12 of the pure chemistry textbook. Right, so let's get started. So for this video itself, we'll be looking at two main sub-concepts. Right, first is actually what exactly are oxidation and reduction, and second is how do we identify and analyze redox reactions. So for this first part of the video, I'm going to focus on how can we actually define oxidation and reduction, and mainly in terms of gaining or losing of oxygen, gaining or losing of hydrogen, gaining or losing of electrons, as well as increase or decrease in what we call oxidation states. Right, so this video will cover all these four methods to determine whether there's oxidation or reduction happening. First and foremost, what exactly is a redox reaction? Now, in case you are still not too sure, you have seen this term called redox quite familiar to you over various notes as well as in the textbook. Now, redox actually refers to a type of reaction whereby there is both what we term as reduction as well as what we call oxidation happening within the reaction itself. Now, what exactly are reduction and what exactly are oxidation? That will be the focus of this video. So hence the name Redox, right? Redox. So in our daily lives, there's actually a lot of examples of redox reactions. One would be the browning of apple, right? If you have ever cut an apple into half, you'll notice how the apple actually turns brown after a while, and that is due to the process of oxidation of the chemicals over there. Corrosion of metal chains, right? You should know that rusting is a very common thing that happens, and rusting itself, the whole process is a type of redox reaction as well. Right, so rusting of iron, like what I mentioned. Now, but even for us as humans, the whole process of aging is actually a type of redox reaction as well, whereby our cells actually undergo certain chemical reactions as we age. So, how can we find out more about oxidation and reduction? Let's first talk about oxidation first, right? So, in terms of determining oxidation, it can actually be defined as a type of reaction whereby there's a gain of oxygen. So, what do I mean by that? Now, focus on the magnesium, Mg, and you'll notice that it actually gains an oxygen to become magnesium oxide or MgO. Now that would mean that there is an oxidation happening because there's a gain of oxygen for magnesium. Another way to determine whether there is oxidation is to look at whether there's a loss of hydrogen. Now similarly, look at this equation here. You'll notice that if you look at the hydrogen sulfide, which is H2S, it actually went through a reaction to become sulfur. So there is a loss of hydrogen, and hence in this case there is an oxidation that's happening. So how do we describe what exactly is being oxidized, what exactly were the changes? So in chemistry, we actually have to phrase our explanation of oxidation in the following way. So we have to say that, for example, magnesium is oxidized to form magnesium oxide as it gains oxygen. So this is using the method of looking at whether it's gaining oxygen. For the second example, we'll say something like hydrogen sulfide is oxidized to form sulfur as it loses hydrogen. So that is using the method of looking at whether is it losing hydrogen to determine whether is it an oxidation. Right, so there's two methods on this slide. One is to look at gaining of oxygen, the other one is to look at the losing of hydrogen. Both can be used to determine whether an oxidation has happened, so it really depends on what kind of reaction you come across. The third method is to look at whether there's a loss of electrons. Right, so if you look at this example over here, you'll see that there's zinc, Zn, reacting with copper 2 ion. Right, so this is Cu2 plus. This forms Zn2 plus ions as well as copper. So if you are familiar with the charges and your ions, you'll notice that actually what happened over here is that the zinc actually undergone a reaction and it lost 2 electrons. That's why there's a 2 plus charge. Right, in case you forgot about your charges, when an atom, which is zinc over here, Zn, becomes a positive ion, there's actually a loss of electrons because electrons are negative. And therefore, how do we describe this? We say that zinc is oxidized to form zinc 2 plus as it loses 2 electrons. So that's the third method of looking at whether oxidation is happening or not, which is to look at whether the chemical is losing electrons. So we have covered 3 methods so far: whether it gains oxygen, whether it loses hydrogen, or whether it loses electron. Right? Either of these methods will work depending on the equation that you are looking at. So that is for oxidation. Now what about reduction? Actually, it's pretty straightforward. Reduction is just the opposite of what you notice for oxidation. So reduction, one of the methods to look at it in terms of oxygen, is that there's a loss of oxygen. So same thing, look at this equation, you realize that iron 3 oxide, which is represented by Fe2O3, actually went through a reaction to become Fe. Now this will mean that it lost oxygen, right? Therefore, this is a type of reduction, right? So this is the entire opposite of what we went through in the previous few slides. The other way is to look at hydrogen. Now this time round, we say that reduction has happened when there is a gain of hydrogen. So if you look at this again, you'll notice that the chlorine here, Cl, actually went through a reaction to become HCl. So that is a gain of hydrogen, and that is a method to determine whether there is reduction or not. So how do we phrase this? We phrase this as iron 3 oxide is reduced to form Fe, which is iron, as it loses oxygen. And for the second example, chlorine is reduced to form HCl as it gains hydrogen. I hope you are getting the hang of it and you realize that how we actually phrase the term, the explanation itself, right? It focuses a lot on, first, looking at what is the chemical that we are looking at, which in this case is iron 3 oxide, and then looking at what is the final chemical that we're looking at. So in terms of phrasing of the explanation, you always phrase in terms of who is the reactant, and then what is the product that's being formed, together with your explanation, be it looking at gain or loss of oxygen, or gain or loss of hydrogen, or electrons. Right, so there is a standard way to phrase it, and it'll take some practice for you to get a hang of it. Of course, how can we forget the third method, which is to look at electrons, right? So in terms of electrons, it's the opposite, which means that reduction is the gain of electrons. So over here, what does it mean by gain of electrons? If you focus on the Cu2 plus ion, you realize that it actually went from Cu2 plus to Cu, and that itself is a gaining of electrons because it went from positively charged to no charge, right? So how do we describe this? We say that Cu2 plus is reduced to form Cu as it gains 2 electrons. Right, so by and large, this is actually how we go about describing whether an oxidation has been happening or whether a reduction has been happening. So we spoke about 3 methods, looking at oxygen, looking at hydrogen, or looking at electron. Now, which do you look at really depends on, number 1, whether the question actually wants you to choose a specific method. Number 2, whether the equation actually allows you to use that method or not. Right? So there's some self-practice questions in your notes itself. So do take the time to try out the questions. There's an example being done over there in terms of the phrasing. Try to practice the phrasing, improve on it as it goes. Right, once you are more or less ready with the self-practice for the oxygen, hydrogen, and electrons, you can move on to the next part of the notes where we'll be talking about this thing called oxidation state. Now, oxidation state is actually the 4th method to determine whether there's oxidation or reduction. Now, being the 4th method is actually the most tedious method, but it is the most effective method to determine whether there's oxidation or reduction. So what is oxidation state? Oxidation state actually refers to the charge that an atom or an element will have if it existed as an ion. So I just want to highlight that this is if it existed as an ion. That means even if the thing is a is a covalent substance, we can still determine oxidation state. So oxidation state is not really a charge, right? I just want to highlight over here, just in case some of you are confused, right? It is not exactly a charge. It's basically something that we give to a chemical or an atom or an element if it is an ion, but that thing may not be an ion, right? So we use this actually to help us calculate certain changes, and then we'll know whether there's whether there's reduction or oxidation happening or not, right? So it's written very differently from charges, so you need to know that if a charge is written as 2 plus, your oxidation state is actually written as plus 2, right? So do take note, I know it's a very, very small difference over here, but you really need to take note of how the symbol of positive in this case actually swaps, right? So oxidation state is always written in terms of the plus first followed by a number, right? So try to get a hang of it. It'll take a while, but eventually you'll realize the difference, right? But in terms of oxidation state, how do we even know what is the number? Now, in order to do that, there's actually a few rules that we'll need to remember, right? And with practice, it'll come a lot easier. The first rule says that actually all free elements, the oxidation state will always be 0. Now what do I mean by a free element? Free element will refer to things like, for example, just Cu, copper, as a chemical, just copper. Sulfur as a chemical, just sulfur. Cl2 as a chemical, just chlorine. I can add a few more examples, like let's say oxygen, which is just O2, nitrogen, which is just H2, maybe helium, which is just He. Now these are all considered free elements, which means that they are just elements. It's not a compound, it's not in any other form, right? So as long as you have a free element, their oxidation state will always be 0. Later we'll apply this and we'll see how actually it works out. Now the oxidation state of a simple ion, that means if you have an ion with you, basically just look at the charge. Right? So for example, Cl minus over here, since it's a charge of 1 minus, the oxidation state will be -1. Take note of how the symbol actually comes to the front, right? We mentioned just now that the positive or negative is actually at the front over here for oxidation state, right? But if you look at the ion itself, you'll notice that the charges, the positive and negative, is actually at the back of the number, right? Just to give a few examples over here, right? But we do a swap, right? So if you have O2 minus ion, the second one over here, the oxidation state will be -2. So that's how it works. If you have zinc 2 plus, it'll be +2. K plus, it'll be +1, etc. So that's the second rule, right? So total there's 4 different rules that we must remember. Number 1, all free element, oxidation state is 0. Number 2 is an ion, it is basically the same as the charge. Now for the third rule looks at what if you have a compound, right? So in a compound, if the compound has no net charge, that means you look at this thing like CaCO3, right, as a formula, right? That means there is no charge outside, just neutral. Then all the oxidation state inside must add up to 0. That means that everything that you calculate must add up to 0 because the compound has no net charge. Now, how does this work? Before we go on further, I just want to highlight maybe just 2 more rules that I need you to help me to add in. 2 very smaller rules. Number 1, just write it down into your notes, alright? So in a compound, oxygen is usually -2 for the oxidation state. Right, so if you have a compound, the oxygen atom is usually a -2. The other small rule is that in compound, hydrogen is usually a +1. So I said usually because there will be some exceptions that you'll realize in questions to come, right? But for now, this should be okay, right? So in compound, oxygen is usually a -2. In compound, hydrogen is usually a +1. Now, how does this apply to rule 3? Rule 3, if you look at the formula inside, there's actually 1 of the calcium, 1 of the carbon, and 3 of the oxygen. Now, what I said just now, if oxygen in a compound is usually a -2, that would mean that there's 3 of them, therefore total, actually the oxidation state that comes out from there is -6. Right, so if you look at this last row over here, this will be 3 times the -2 and you have -6. Right, that's how we go about. If you look at calcium, we know that in such a chemical, it's actually an ion because it is actually a Ca2 plus group 2 ion. And remember that in the previous rule, we said that if there's an ion, then the oxidation state is actually the same as the charge. That's why it's over here written as +2. Now, once you have figured out your calcium, which is based on the charge, once you have figured out the oxygen, which is based on what we said, every oxygen is usually a -2, you realize that there's a -6 here, and there's a +2 here, but eventually there cannot be any charge. This will mean that this carbon here must be equivalent to a 4, because +2 plus 4 will -6. This will actually add up to become our 0 that we want, because this compound here has no net charge. Right? Later we'll be doing some examples, so hopefully it is a bit clearer. Rule 4. Rule 4 says that if there is, however, a charge now, so let's say you're looking at sulfate ion, so you know that sulfate has an SO4 2 minus charge. That means that overall, when you add up all the oxidation state, you must end up with 2 minus. Right, so what does this mean again? Same thing, let's look at in sulfate, right? There will be a total of 1 sulfur and 4 of the oxygen, right? Of which each of the oxygen, like what I said just now, in a compound is a -2. You have 4 of them, so it's going to be 4 times -2, which is going to be a -8. Now, how do you know what's the sulfur? We know that eventually the number must add up, not to become 0, must become a -2, because there is this charge over here. This -2, this -2 over here, and this -2 over here, they must actually match. This will mean that actually the sulfur, the oxidation state, will actually have to be a +6, because +6 and -8 is a -2. Right? So take note of how this actually comes about in terms of how we actually calculate the oxidation state. Right? So now let's try to put this into practice. It'll take a while, but we'll try to work out the steps together so that we all get a hang of it. Okay, so in terms of practice, let's try this out. The first one, H2S, we are looking at the oxidation state of the underlying element. So if you recall just now I mentioned that in a compound, the hydrogen is usually a +1, right? So what this means is that inside here, we know that there's actually 1 of the sulfur and there's actually 2 of the hydrogen. Correct? So like what I mentioned just now, together, if you look at their sum, it must add up to 0 because H2S has no charge. So this will mean that based on this thing, if I say that just now each of the hydrogen is usually a +1, so if I ask you to tell me what is the sulfur that can eventually give me a 0, you realize that since the hydrogen there's 2 of them, right? So it's a 2 times +1, so that's a +2. How can that become a 0? That's when you deduce that. That means sulfur must be a -2. Okay, so that's actually how we go about. So let's try out another one. NO3 minus. Now, same thing inside here. You realize that there's 1 of the N, there's 3 of the O. Okay, so if you recall what I said just now, in the compound, each of the O is usually a -2. So there's actually 3 sets of them. And together, when you add them up, it must be equal to the charge, because over here there's a charge now. So now there must be a charge here, which in this case is a -1. Just a minute. Yep, so it should be a -1 in this case. So then you ask yourself again, then what should N be? Because oxygen, 3 of them, 3 times -2, that's a total of -6. So what can N be to give me a -1? If you play around with numbers, you realize that, oh, that means N must be a +5. Right? So try this out yourself for each of the following one. You may want to pause the video at this point so that you can give yourself some time to practice. Usually at the start, it takes about maybe 30 to 40 seconds for you to get a hang of it. But eventually, you'll be so good at this that it will just take you maybe 5 seconds max to work it out. Right, so you might want to pause the video now because we'll be revealing the answer in the next 3 seconds. Okay, so now we'll take a look at what are the answers. So check with your own work. You should be able to deduce this respective oxidation state. If you have managed to, congratulations, you have understood what oxidation state calculation is all about. Right? If you have not been able to do so, don't worry, there will be more opportunities for you to practice. So why are we talking about this oxidation state? It's actually because this is the last method to determine whether there's an oxidation or a reduction. Now, if there's an increase in oxidation state, that will actually be an indication that oxidation has happened. So now that you have learned about oxidation state, let's try to apply it over here. You'll recall just now that my rule number 1 is that free element, their oxidation state is actually 0. Ions is actually same as the charge. So with that, actually I can deduce that the first zinc oxidation state is actually 0. Copper is +2 because the charge is 2+. Zinc is +2 because the charge is 2+. And then the last copper here, because it's just an element, no charge, nothing, the oxidation state is 0. What happened? The zinc actually went from an oxidation state of 0 to an oxidation state of +2. Right, so that is actually a sign of oxidation happening. Now what is reduction? Similarly, the opposite works. A decrease in oxidation state. So if you now look at the same set of numbers, you realize that the copper actually went from +2 now to 0, and that's where we see that a reduction has taken place. how do we phrase this out, like what we do in the previous part. Now, it's a bit longer, but this time around, we have to describe about the oxidation state. So, zinc is oxidized as its oxidation state increases from 0 in zinc to +2 in zinc 2 plus. Now, a lot of students tend to miss out on this, and teachers always remind, because this is the part that will actually cause a lot of students to lose mark. Because we have to describe about the changes, right? You need to tell us what is it from and what did it became, and it's very important to talk about what's the chemical. Same for the other one, copper 2 plus is reduced as its oxidation state decreases from +2 in Cu2 plus to 0 in Cu, and that's actually how you go about describing a reduction in terms of oxidation state. So try out the practice questions in your notes as well, then you can discuss this further with your teachers. So in general, just to sum up everything, there's actually a shortcut to remember which I'd like to tell my students. Basically, to know whether there's an oxidation that's happening, I will say this acronym OX, GO, LAY. Right? GO means gain oxygen. So oxidation means you gain oxygen, or the lay means you lose electron or you lose hydrogen. And the last method is, of course, do you gain in terms of the oxidation state. So to just summarize everything that we have went through just now, we have actually learned about 4 different methods to look at whether there's oxidation or reduction. And the good news is, just remembering one of them, right, just oxidation, you can apply it because reduction will be direct opposite. So if oxidation is gain oxygen, reduction must be lost. If reduction is gain hydrogen, oxidation must be lost hydrogen, right? And if you remember your ox, go, lay, you should be able to figure out all these little changes. So it's not too hard to remember what's the 4 methods. What is more difficult is to phrase it out, right? Hence that requires a bit of practice. So in summary, this is what we covered in this first video, right, in terms of the oxidation and reduction. In the second video, we'll look at how do we determine whether a redox reaction has happened, and to look at what we call reducing agent and oxidizing agent.